Doubt in order of reaction? Do you have any doubt in the order of reaction?
No, sir.
So let's just start with a question. That question is very easy. Okay, not a question. I'm going to start a new topic related to this order of reaction. That is basically unit of rate constant. I'm going to talk about unit of rate constant. Unit of rate constant. So basically rate constant K has different units for different order of reaction. If we are talking about this, wait a minute. So what I told you is that different order of reaction will have different unit of rate constant. Let's say we have a reaction. A is converting into product. A is converting into product. And there is a rate law expression for this reaction. Rate is equal to K into A raised to the power N. And this power basically shows you the order of reaction. N is basically order of reaction. Order of reaction. Now, if we are going to calculate unit of rate constant K for zero order reaction, as you know that means basically N will be equal to, since it is zero order, it will be equal to 0, and you can see rate will be equal to K into A raised to the power N. So I'm going to write this formula in the form of K. K will be equal to, can I write rate upon A raised to the power N? Now see, in order to calculate the unit of rate constant, what is the unit of this rate? Rate has a unit, that is mole per liter per second. Rate will have a unit mole per liter per second. So I'm just going to write that mole per liter. This is your mole, then per liter per second. And you can see this is concentration. So I'm going to write mole per liter raised to the power. Since we are talking about zero order reaction, so the power will be 0. Now you know that anything which has power 0 will have value 1. If A raised to the power 0, it will have value 1. If 1 raised to the power 0, it will have value 1. If 10,000 raised to the power 0, it will have value 1. So the denominator becomes 1 and numerator will be mole per liter per second. So the unit of rate constant K will be mole per liter per second. Mole per liter per second. Now we are going to talk about first order reaction. Unit of rate constant for first order reaction. For first order reaction. Now, it's very easy to understand. Can I write it? K will be equal to rate upon K raised to the power 1. This power determines whether which order of reaction is this. So rate will have a unit that is mole per liter per second, and you know that concentration will have unit mole per liter raised to the power 1. So you just need to solve it, mole per liter per second upon mole per liter. Now you just need to cancel it. This will be cancelled by this will be cancelled by this. So per second is the unit of rate constant for first order reaction, and it also shows that first order reaction is independent of, it is not dependent, it is independent of initial concentration, since it only depends on time per second. It depends. So please do write it and let me know when you are done with this. Nafisa, Nafisa, are you there?
Yes, sir. My internet is bad.
What you just said?
I have a bad internet connection.
Okay. So have you got all this? Did you understand this? The unit of rate constant, or should I repeat it? Should I repeat it? Please do write it and let me know if you have any doubt. Lakshita, are you done with this?
No, not yet.
Okay, please do it and let me know if you have any doubt. Then we will move ahead.
Sir, can you scroll down?
Yeah. Wait.
Yes, sir, finish.
Okay, so do you have any doubt in this?
No, sir.
Okay, so I'm going to ask you to calculate the unit of rate constant. The unit of rate constant for following order of rates. For following order of rates. First is second order reaction. Second order, that means basically n is equal to 2. And the second is 3 by 2 order, that means n equals to 3 by 2. N equals to 3 by 2. And the third is basically nth order, that means n is equal to n order. So please do this question, then we will move to the next. Let me know if you have any doubt.
So the first one is s minus 1 raised to the raised to the power of minus 1 by mole L raised to the power of 1.
Just let me check it in front of you. See, K will have this rate upon A raised to the power 2. That shows it is second order reaction, and rate will have a unit mole per liter per second upon mole per liter, since it is concentration square bracket raised to the power 2. Now, this will be basically mole per liter per second upon mole square and liter raised to the power minus 2, because it has a square. Now you need to just solve it. You know, in numerator you have mole raised to the power 1, and in denominator mole raised to the power 2. When it will move to numerator, the sign will be changed, 1 minus 2, and now you can see this is minus 1, and this is -2. When it will move up, it will be minus minus plus, there will be +2, and per second it will be as it is. Then you will get mole raised to the power -1, liter raised to the power 1, and per second. This is the unit per mole liter per second is the unit of rate constant for second order reaction. Did you get it? That's all
Yes,
mathematics.
sir.
Okay, do the second and third. Let me know when you are done with this. Nafisa, can you do this or should I explain?
Sir, can you explain?
Okay, it's very easy. I'm going for 3 by 2 order. See, it's maths more than the concept. The concept needs maths. K is equal to rate upon a raised to the power n. Now, the second question says that it is 3.5 order, right? This is the order. Now, you're going to solve it. What is the unit of rate? Rate is a unit, mole per liter per second. And what is the unit of concentration? It is mole per liter, and which has a rate, which has a power 3 by 2. Is that clear?
Yes, sir.
Now you can see that in numerator it is mole per liter per second, but in numerator it is mole raised to the power 3 by 2. So I'm going to write mole raised to the power 3 by 2 along with liter raised to the power minus 1 raised to the power 3 by 2. So I'm going to write liter raised to the power minus 3 by 2. Are you getting my point?
Yes, sir.
Now see, it's very easy to calculate. You can see in numerator it is power 1 and in denominator it is power 3 by 2 and base are same. So I'm going to write mole raised to the power 1, and when it moves to numerator there will be negative sign minus 3 by 2. And you can see this is minus 1 and this is minus 3 by 2. When it will move up to numerator there will be negative sign, and there is already negative sign which will make it positive, so plus 3 by 2 per second. Now you just need to solve this equation. 1 minus 3 by 2, that means minus 1 by 2, and it is 3 by 2 which is in positive minus 1, that means plus 1 by 2. So basically your answer will be mole raised to the power minus 1 by 2 liter raised to the power 1 by 2 per second. Are you getting my point?
Yes, sir.
So please do write it. If you still don't get it, please let me.
Yes, sir.
So the last question, can you attempt it for nth order? Can you do this? In terms of n, the answer will be in terms of n. Or should I explain? Just let me know.
I'll try to do it.
Okay, I'm waiting.
Sir,
Yes. Are you there?
Yes, yes, sir.
Okay, just match your answer with mine. So I'm just gonna explain it again. So you know that k will be equal to rate upon e raised to the power nth order. So I'm gonna put n at the place of order. What is the unit of this rate? As you know that this will have unit mole per liter per second upon A, that means concentration mole per liter raised to the power n. Again, you can see this is mole per liter per second, and in denominator, mole raised to the power n there will be, and then liter raised to the power minus. Now again, solving the equation, I'm going to simplify it. When it moves in numerator, there will be negative sign, and then when it will move to numerator, there is negative already, and there will be negative. Negative will be positive. Are you getting this? Negative positive.
Yes, yes, sir.
So it will be mole raised to the power 1 minus n, liter raised to the power n minus 1, and per second is the unit of rate constant for nth order. Okay,
Yes, sir.
so let's start a new topic that is known as molecularity. Molecularity. See, what is molecularity? It's very easy to understand what is molecularity. Molecularity is basically how many molecules are interacting in the reaction. We can say how many reactants are interacting with each other. That is called molecularity, and I'm going to define it like right with me. Total number of either it can be molecules, it can be atoms, or it can be ions, or we can write basically the reacting species in a reaction. Reacting species. Species stands for all these atoms, ions, molecule participating in a chemical reaction, participating in an elementary reaction is called molecular. Is called molecularity. This is the definition for molecularity. First of all, there is an important point, that is, it is theoretical quantity. It is theoretical quantity, not experimental quantity. It is theoretical quantity. The next point, this is also very important. It is an integer. It is generally it is positive integer. Basically, it is an integer like 1, 2, 3, etc. But it cannot be. But it cannot be fraction or zero like order of reaction. Order of reaction can be fraction, zero, positive, anything. But molecularity cannot be fraction or zero. It will be positive integer. Now the next point, which is also very important, I want to ask a question. Do you know what is elementary reaction and what is a complex reaction?
No, sir.
See, elementary reaction is the one which complete itself in a single step. Single step reaction is that the single step reaction is elementary reaction, and complex reaction basically proceeds proceeds in more than one step. Got it?
Yes, sir.
So in an elementary reaction, molecularity of a reaction is equal to the order of reaction. Order of reaction. First of all, molecularity is only defined for elementary reaction. It has no meaning for complex reaction, whereas order of reaction can be defined for elementary as well as complex reaction. Is that clear?
Yes, sir.
So please to write it. Total molecularity of a complex reaction can never be elementary Wait a minute. So, total reaction of a complex reaction is meaningless. Right.
Yes, sir. Finish.
Well, now I'm going to talk about pseudo first order reaction. Pseudo first order reaction. See, pseudo first order reaction, we can define it like the reaction in which order of reaction is 1, but molecularity is greater than 1. That type of reaction is known as pseudo first order reaction. So I'm just going to define it. Oh, wait a minute. A chemical reaction in which value of order of reaction is 1, but molecularity is more than 1 is known as pseudo first order reaction. Pseudo first order reaction. That means basically you can understand order of reaction is 1 and molecularity greater than 1. That type of reaction is known as pseudo first order reaction. I'm going to take an example, CH3COOC2H5, which is an ester, reacting with H2O in the presence of H plus. And here the H2O is in excess. So I'm going to take it as the product will be basically CH3COOH and C2H5OH. This is the product. You will learn about this in organic aldehyde and ketones and carboxylic acids happen. If you are going to calculate the rate of reaction, rate will be basically K into CH3COOC2H5 rate law expression and H2O. Rate law expression is always in terms of reactant. But since H2O is in excess and this is constant, H2O, we take H2O as constant. So K into H2O will be a new constant that is denoted by K dash. So rate will be equal to K into H2. I'm going to take it as K dash and then CH3 COOC2H5. Now this is the rate law expression modified. This is the final, which has a power 1 that represents order of the reaction is 1, but the reacting molecules or species present here is 1 and 1, 2. That means the reaction is bimolecular. So you can see order of reaction is 1, but the reaction is bimolecular. So it is a first pseudo first order reaction. Is that clear?
Sir, can you explain again?
Wait a minute. Yeah. Which is your favorite chocolate? This is a question. Lisa, am I audible?
No, I was lagging, sir.
Okay, so just see. Which is your? Can you name your favorite chocolate? Am I audible clearly? Nafisa?
Yes, now you're audible.
Okay,
I was lagging. Sorry.
okay, no problem. Can you name your favorite chocolate?
Yes.
Yes, just name it. You are not audible. Am I audible clearly?
Yeah, now you are. Yeah.
Okay. So I asked something. Please do answer me. I'm gonna explain with that.
Did
I
you
will take
just
that
you asked me my favorite
chocolate.
chocolate?
Yeah,
Oh,
yeah.
Kit Kat.
Kit Kat. If you got Kit Kat, just taking an example, if you got 1 billion Kit Kat chocolate, if you are going to start eating, with respect to time, Kit Kat will be constant. Will it end easily? Will you finish it easily if
No.
you no? So can I take this Kit Kat as constant because it will not finish easily, or it will not finish fast, or you can say uh, it will finish so slowly that we cannot even think. Are you getting my point, Nafisa?
Yes, sir. Yes,
Okay.
sir.
So since H2O, we just take see. I'm going to come to the point. Pseudo first order reaction is the reaction in which order of reaction is 1, but the molecularity is 2. Now, can you see how many molecules are reacting here? Can you tell me how many molecules are reacting here? Two molecules, one molecule of ester and one molecule of water. Yes or no? So total molecules reacting in this reaction is 2. That's why it is bimolecular. Am I audible clearly?
Yes, sir.
So it is bimolecular. Now come to the rate law expression. If you are going to write the rate law expression, K into CS3, COO, C2H5 and H2O. Since H2O is in excess, I just took H2O as constant and K into H2O will be treated as constant. That is a new constant K dash. So K into H2O, I just denoted with K dash, and the rate law expression is now this. Now, can you find the order of reaction after seeing this rate law expression? What will be the order of reaction? What will be the order of reaction? You are not audible. Nafisa? Nafisa, am I audible? Nafisa, are you there?
Yes, sir.
Did you hear whatever I said, or should I explain it again? Please do let me know.
Sir, can you explain again?
Yeah, see. What is pseudo first order reaction? A reaction in which order of reaction is 1 and molecularity is more than 1. So can you tell me how many molecules reacting in this reaction? I'm going to write it again. Please do focus here. This is CH3 C2H5, and then reacting with water to give CH3 COOH plus C2H5OH plus C2H5OH. Can you tell me how many molecules are reacting? One molecule of ester, one molecule of ester, and one molecule of water. Is that clear?
Yes, sir.
So how many total molecules? Is two molecules. Are you getting my point? So it is
Yes, sir.
bimolecular. It is bimolecular, or you can say molecularity is 2. Molecularity equals to 2. Now come to the order. If you are going to write the rate law expression, rate will be equal to K into CH3 C2 into H2. Now H2O is in excess, like your Kit Kat. So K into H2O will be equal to K dash. This will be constant again, and this is the constant. So multiplying this, there is a new constant K dash. Now the new rate law expression will be equal to CH3 C2H5. Now, can you tell me the order of reaction after watching this rate law expression? Can you tell me the order of reaction? Wait a minute. Can you tell me the rate of reaction? Yes or no?
No, sir.
Oh, it's very bad. What I told you, the rate, if any rate law expression is given like this, a raised to the power x and b raised to the power y, or anything like k into a raised to the power x only, what you need to do? Order of reaction is the sum of powers, and only there is one power. Order of reaction is x here, and here order of reaction is x plus y, and here order of reaction is
Yes.
1. Please do write it. Nafisa, in tomorrow's class, you are gonna study about it. Then I'll see you uh, in tomorrow's class. And please be focused because it's your exam stand coming.
Yes, sir. Okay.
Are you done with this?
Yes, sir.
Okay, write the question and then we will leave the class. I'm gonna give you a homework, a reaction of second order with respect to reactant. How is the rate affected if the concentration of reactants falls A part is double and B part is half. So this is the question for you. Please do write.
So what's B?
B is half. Half, it is half. Okay.
Yes, sir, finish.
Okay, thank you so much. I will see you tomorrow.
Thank
And
you, sir.
please make sure that your Wi-Fi is working. Okay.